Thanks, Gordon, and good afternoon, everyone. So I'll be talking a bit about what we know about chickpea viruses, and I guess touching on some of the things that we don't know about them, and I guess looking a bit further into the future about management options for that. I'll be presenting some of the work that I've done on the diagnostics and the diversity of viruses in chickpeas recently, but also using some of the data that Kevin Moore and Andrew Varel have generated over the last few years, and also some results from Job van Leur and Mohammed Aftab. So I guess starting with the take-home messages. Last year during the surveys, there were still some areas that had quite high levels of virus in the northern region, similar to what was seen in 2012. And the diversity of viruses in chickpeas is quite different between the regions, so moving from north to south, and I'll be talking a bit about that as we go through. Standing stubble reduces the incidence of viruses in chickpeas, and a higher plant density, we're sort of recommending above 25 plants per square metre, reduces the incidence of virus as well, as Andrew was just mentioning before. Also, some of Andrew's previous work and the agronomy side was that they showed that really, having a well-nourished crop, a good healthy chickpea crop is less impacted by virus. And obviously controlling the source of the virus from around the crop to minimise the chance of it moving in. So controlling broadleaf weeds in and around the crop, and also avoiding known sources of virus such as pasture legumes like lucerne. So what happened in 2013? Well, viruses were found in just about all chickpea crops that were inspected across the northern region, but generally though the incidence was quite low, less than 5%. However, there were some regions where there were several crops where it was much higher, sort of 30 to 50% infection. Those worst hit areas were around the Liverpool Plains, which has had a history over the last few years of quite high virus incidence, and also north of Narrabri around Edgeroy. Now, there's a whole range of viruses that can affect chickpeas. There's sort of around in the ballpark of 14 different viruses which have been reported from chickpeas, but there's only about a handful which regularly get into them and cause damaging levels, and almost all of those, are transmitted by aphids. Other possible insect vectors include thrips and whiteflies and leafhoppers, but generally all the damaging viruses are transmitted by aphids. So this is an example of a crop which has got a higher level of incidence. So you can see the diseased plants scattered right throughout the crop. So this is, I guess, an important point also is that quite often these crops which have got higher incidence, the distribution of affected plants is scattered throughout the crop. So there isn't really a really noticeable edge effect, which sort of indicates that the aphids are flying in from some distance away and bringing the virus in from sources which we're not really sure of yet, and then scattering it right across the whole crop. Now, also an important point in here is if you notice the bare patches in the foreground, which are really common throughout the crop, and quite a low stubble level, which are two risk factors that we think increase the chances of getting virus in chickpeas. So, so basically that crop didn't really have a particularly good canopy closure. Okay, so let's talk a bit about the viruses that get into chickpeas, the diversity, and how that changes between across the region. Now, what I've done is just listed the sites where we did surveys from north to south, so Boomy in the north right down to Wellington in the south, and then the four main viruses that we commonly find in chickpeas. This is beet western yellows virus, which is actually a complex of different virus species. We're finding that they're getting confused and being called the one thing, but there's actually multiple viruses. Alfalfa mosaic virus, AMV, bean leaf roll virus, and cucumber mosaic virus. Now, what I've done is just highlighted in colours the higher incidences that occur. Now, also an important point is that this is the proportion of virus species, so it's not suggesting that 100% of the crop at Boomy was infected, it's saying that 100% of the virus-affected plants were beet western yellows. Now, anything above 40%, I've put in yellow or orange there, and then anything above 60% is in red. So hopefully what that shows is that basically in the northern region, sort of somewhere north of the Liverpool Plains, it was completely dominated by beet western yellows virus complex, whereas south of the Liverpool Plains, down towards Wellington, was dominated by AMV, alfalfa mosaic virus. Now that's almost certainly going to be related to the source of the virus around the crop, and so that may suggest that perhaps further south that there's a greater source of AMV near the crops, maybe forage legumes like lucerne. So I guess the question is, why do we need to know the accurate idea of these viruses? The end result's the same. We know that the plants generally die if there's an early infection with virus. So what does it really matter to the management of the virus as well? I guess if you're just talking about agronomic measures that you can take for aphid-transmitted viruses, then the recommendations probably will be very similar across the different virus species. However, one good reason to know is in the long term, if we want to have durable genetic resistance from the germplasm screening that's taking place, we have to know which viruses we're dealing with, particularly at the screening stage. And then also the viruses quite often will have different vectors and different host range. So as an integrated management package, you really need to know which viruses you have so that you can target the likely alternative host around the crop, and also the known vectors which are moving the viruses around. And as I said, currently at the moment, this beet western yellows virus complex, it's a group of viruses which are being misdiagnosed as one species. So we've started to develop a more accurate molecular diagnostic test to try to answer some of these questions around what's really in this complex here. And I guess an example of that is some data from last year. So we tested a small number of those plants from the crops taken around Edgeroy and north towards Boomy. So of the 48 plants that were tested by the molecular assay that were beet western yellows virus-like, actually 38 of those were soybean dwarf virus, a completely different species. 5 of them were a new species that we're tentatively calling phasing bean virus at this stage, which is actually, it's a fairly low number from last year, but in 2012, we think that it accounted for about 30% of the infections that were thought to be beet western yellows. And it's actually very widespread. It's been identified in Victoria and Tasmania as well, so it's probably been misdiagnosed for a very long time. It's very common. Only 3 of the plants that were originally thought to be beet western yellows were beet western yellows, and 2 of them were bean leaf roll as well. So there's obviously some confusion about the true identity of these viruses. Now, moving on to some of Kevin Moore's work from last year. So Kevin ran a small plot trial at the Tamworth Research Station to try to answer the question, do you get a difference in virus incidence if you're planting chickpeas into standing stubble like this or flattened stubble? And quite clearly the answer was yes, you do get an effect. Planting into standing stubble, which is the blue bars on the chart here, you get a lower incidence of virus compared to the flat stubble in yellow. This is the same site, just rated on two occasions. And on the y-axis is the virus plants per plot, so per 40 square metres of plot. And I've just translated that to a virus incidence over here. So it was up to about 5% virus incidence. Now this trial data also supports a number of anecdotal field observations throughout the northern region, which were suggesting that planting into standing stubble did actually have an effect. Okay, so this is some of Andrew Varell's data. Now, Andrew was looking at the relationship between virus incidence and plant density. So he ran a whole bunch of different plant densities going from 5 plants per square metre right up to 45 plants per square metre. And on the x-axis is y-axis is the number of plants with virus, as in plants per square metre. So what it's telling us is that when you get less than about 20 plants per square metre, you actually have about 3 to 3.5 plants in a square metre with virus. Now that has a bigger impact when you've only got 5 plants per square metre. You've got about 60 to 70% of your plants infected. when you actually get above 25 plants per square metre, you have significantly less plants infected, so only around 2 or 1.5 plants per square metre. And that's, you're only 2 plants out of 30, you're only looking at about 6%. So it's a 5-fold decrease in virus incidence, or proportion of virus, I should say. Okay, so some more of Andrew's work recently from last year. In a related trial, they were looking at, well, actually, Andrew was just talking about that, so the effect of row spacing, and they noticed that there was an effect on the virus incidence. So, again, this is plants with virus in over a 20 square metre plot, and I've translated that into virus incidence here. So the virus pressure was very low, so it was only up to 1.5% of the of virus incidence in the crop. But there did seem to be an effect with the wider spaced rows. Now, the plant density, the important point here is that the plant density was the same. So there's twice as many plants per lineal metre in that 80 centimetre row. So we think that the effect is probably more the density of the plant in that lineal metre is much higher. So it's sort of, I guess, the same as having a higher density per square metre, or a more uniform canopy in a lineal fashion. But we don't really know exactly what the effect is, but it obviously probably justifies looking at it a bit more closely, and particularly under a higher pressure, to see if that effect actually holds up. Now, obviously, the long-term strategy would be to have durable genetic resistance. So they looked at, this is again Andrew's data, so looking at across 5 different varieties to see if there was an effect of virus incidence. Last year there did seem to be a bit of an effect. Again, the pressure was quite low, so it was only up to a maximum of 6%. But it did seem like there was a couple of varieties that had lower incidence. However, the backstory to that is that the same varieties were run in a trial in 2012 and there was no effect. So obviously this might give us some indication that something's happening, but we need to look at it a bit more carefully. However, having said that, there's some related work was carried out by Job van Leur last year, where he's running a whole range of germplasm in a very high pressure field trial with a lot of virus coming in from surrounding areas down at Breezer. And he found that there's a few varieties, including one of these old varieties, Gully, which actually have quite good tolerance to virus infection. So hopefully in the long term there'll be some promise to be able to integrate that into the elite lines. So I guess coming back to the main points, or the take-home messages, standing stubble reduces virus infection. Aim for a higher plant density, certainly above 25 plants per square metre is recommended. And aiming for adequate nutrition, good nutrition, a healthy crop is much more likely to do well. And obviously, where possible, control broadleaf weeds and avoid pasture legumes next door, which are a known risk factor. So you should be aiming for, like, this is the same photo that Andrew showed, it's a good crop planted into standing stubble, good even canopy closure. Well, this was around Edgeroy in 2012. Nearby, like a couple of kilometres away in each direction, there were crops that had quite a poor plant stand and had up to 50 to 60% virus infection. This had about 3%. So you can see that we think that that's why there's an effect of this standing stubble with and a good canopy closure, reducing the risk of virus infection. And thanks very much. Thanks to GRDC and growers and agronomists.
Most chickpea viruses are lethal. So if the virus comes in early in the season and the plants are small, they die and healthy plants compensate for them. Unfortunately, most chickpea viruses tend to come in later in the season and the crop doesn't have time to compensate. So a good way of assessing yield loss from chickpeas is to go out in spring and count the number of dead plants you've got.
Vectors. I mean, we've talked about the row spacing, stubble, all that sort of thing, but no comment about targeting the vector, the aphid. Where are we at with that sort of idea?
Okay, well, yeah, so each virus is probably transmitted by one or more. I should go back a step. So when I say there's aphid transmitted viruses, there's two main groups. So there's ones which are persistently transmitted, and they are generally very specific to the aphid species that will transmit them. So there's usually one or two aphid species which are associated with their transmission. However, there's other aphid transmitted viruses like AMV and CMV, which are basically transmitted by any aphid that happens to be feeding, that they just pick it up and then move it very quickly. As far as controlling the virus through controlling aphids, it's been shown to be not effective. Again, Kevin Moore has done some pretty extensive work with this years ago, where they tried seed application of systemic insecticides at varying rates, and also foliar applications throughout the cropping cycle, and found no effect on the virus incidence. So I guess that's not totally surprising, because, as Kevin just mentioned, that most of the infections are coming through mid to late cropping cycle. So by that point, if you had a seed treatment, it's lost all of its effect anyway. Seed treatments can be very effective with other crops like faba beans and bean leaf roll virus, where you may get early protection through that systemic insecticide, which reduces the virus incidence, but it doesn't work with chickpeas.